So good morning, everybody. Quite difficult, 8 in the morning to introduce without coffee. I precise, without coffee. First of all, I would like to thank the Honorable Air and Space Academy for giving us the opportunity today to share with you thoughts about AI, and more particularly as an operational head of the FCAS program. So it is therefore quite natural that before talking about AI in the frame of this colloquium, I want to talk a bit about the new generation weapon system, which is the program that we are developing in cooperation with our German and Spanish friends. It's important to keep in mind that combat aviation needs to be continuously modernized to be in order to face the quick evolving threats. That's why there will be first in this combat aviation for France a standard F5 for the aircraft Rafale, and as a next step a global future combat air system in which you will find the new generation weapon system will, and in this FCAS, it will play a central role. That means the new generation weapon system is not a combat aircraft. It is a system of systems natively designed as such. That includes a fighter, as well as drone of all kinds, and we call those drone remote carriers. But above all, the system draws all its power from the combat cloud, into which all the platforms are natively integrated. And that's the difference with what we were doing before. We are not building something, adding something else, adding a cloud, adding connectivity. No, all for the engineer is built as its own, which is not the case for the Tempest. Tempest is at that time called JCAP, and JCAP is just a fighter at that time. And which is not the case of NGAD. But NGAD, you know, has been stopped this summer by the US Air Force. So if we go a bit further in detail, you know that stealth, maneuverability, range, payload capacity, sensors are obviously key characteristics for the fighter. However, I pay a particular attention to interoperability, to connectivity, and above all, the revolution that I want inside the cockpit and the human system interfaces. Likewise, the remote carriers must be multifunctional. And I just give you two main topics or two main characteristics on what I pay attention is it must be a risk taker and an affordable mass generator. Finally, the combat cloud must be designed to multiply the effects and drastically reduce the decision loop, which is the key to operational superiority. That means to pay attention on resilient connectivity, reliable and updated data. I think we will speak longly this morning about data. And we need a relevant network as well, collaborative services, and a high level of cybersecurity. I believe the new generation weapon system for 2040, 2050, and more is a credible answer to the multiple phases of tomorrow's operation, for which you will find a few trends that are depicted, on this slide. But just keep in mind, we assess that we have quick, evolving, and interconnected threats, much more tomorrow than today. A large diversity, or blue forces will face a large diversity of assets, especially air assets. There is another characteristic of evolving threats is a continuous and insidious competition and contestation environment. Competition, contestation, and not only peace, crisis, war. Today we are in competition. Right now we are in competition. We will have to deal with multi-domain operation. You know, you all hear about multi-domain operation. It's a quite simple word, but it's very complicated to build. And the last characteristic is that you will face an acceleration of the operation, an acceleration of the time frame due to digitalization of the battlefield. And yet, in this saturating complexity, human being must keep its place. Whatever you want, inside, nearby, above the loop, but the man must still in the place. And this for a set of reasons, of important reasons that we can evoke later. We will therefore have to seriously help the man in the specific role of a decision taker. So I heard about this famous AI with extraordinary power and capable of many miracles. That's why I'm here this morning. So let's see if this seminar meets my expectation and if AI brings all the answer to my question. Thank you. And I leave the floor to Philippe.
So good morning. As just said by General Moritz, NGWS will be a capability and technology leap in defense. And it will embody concentration of onboard AI application. AI will be integrated at every level, starting from the overarching system of system down to each single subsystem component. So what I propose in this slide is to walk you through how AI will transform every layer of this complex system and setting a new standard in military operations. So let's begin with the system of system level. And that's where AI impact will become immediately apparent. That's where AI will support the implementation of collaborative combat. So starting with the dynamic management of communication network, AI will enable real-time routing, resilient communication, bandwidth optimization, and ensuring critical data will flow where it's needed and when it's needed, even under extreme conditions. Then command and control, the C2 will harness AI potential, making decision-making much faster and more precise. We will shift from reactive to predictive command structures, which will be more distributed and more context-centric. And here, commanders will be able to rely on AI to recommend courses of action, taking into account enemy behavior or mission parameters. And it will allow rapid adaptation and in an evolving environment, and it will allow to bring confusion to the adversary. And AI doesn't stop there because it will be also the foundation for a bunch of collaborative services from collaborative situation awareness to collaborative targeting, orchestrating different platforms, sensors, effectors, and coordinating their response. And this orchestration will give NGWS an edge in the future battlefield. Now, if we move to the system level with the new generation fighter, the NGF, and here AI will bring the revolution into the cockpit. The future pilot will be assisted by an AI-powered virtual assistant, a kind of R2-D2 of the modern pilot. And this virtual assistant will serve as an advisor and as a delegate, able to handle some tasks autonomously and allowing the pilot to focus really on areas and tasks where his human judgment will bring the highest added value. And still in the cockpit, the AI will be integrated with biosensors to monitor the pilot's cognitive state. And you can imagine here a cockpit where the presentation of information will adapt to pilot's stress level or pilot mental load to enhance decision-making under pressure. AI will also provide trajectory optimization and taking into account time, fuel, threat avoidance, or radar cross-section to optimize operational effectiveness. And reinforcement learning will also augment pilot capability for air combat and providing real-time tactical maneuver. Now, if you focus on drones and remote carriers, they will benefit from man-on-man teaming capabilities. And these assets will be operated with high-level command and will function with an unprecedented level of autonomy. And some of them will operate as swarms, coordinating their trajectory, coordinating their actions, allocating tasks, reallocating tasks, and even under GNSS denied conditions, they will function and they will navigate swiftly, leveraging their computer vision capability and leveraging data fusion across various sensors. Now let's move to the subsystem level. AI will augment the sensor performances. Advanced sensor will benefit from automatic target recognition and will adapt the way working. By way working, I mean waveform or field of regard and so on. They will adapt the way working based on environmental and operational conditions. And talking about NGWS, here we won't talk about individual sensors, but about sensor suite. And a digital brain and powered with AI, what we call a digital backbone, will orchestrate various sensors and will fuse their data to provide a comprehensive operational picture. And in the electronic warfare domain, AI will act as a kind of Shazam. It will be able to extract low or weak signal from the surrounding noise to detect and identify threats. And finally, maintenance. Each subsystem will benefit from predictive capabilities, and here we'll shift from reactive to proactive approach for maintenance. AI will be able to detect when a component will fail in order to anticipate repairs and to maximize operational readiness. So you can see that AI will be really at the heartbeat of NGWS. And we open a new era for defense. So that's the vision, and I hope this morning we'll discuss how we will practically achieve and implement this vision. Thank you.